Okay, good afternoon, students, once again. We have many more students joining us. Good. More than 20. Okay. Uh, let's start today's session. What I'm going to do is stop my video, okay, and go to the lecture slides. Please, someone confirm that you can hear me. Anyone? Okay.
Yes.
Thank you. Now, someone else confirm that you can hear the actual, sorry, you can see the video. Can you see the video?
Yes.
Okay, we start with the presentation of arrays and structures. Now, the whole concept of arrays and structures is fundamental to any programming language. Any programming language that you can think of, arrays and structures is a fundamental concept. Okay, in fact, we have got many data structures, the most fundamental of them being arrays. Okay, we have still students coming in. We have got arrays, structures, trees, okay, linked lists, so many. But we only go through arrays and structures. If you do computing, you study much more. Now, I have some explanatory slides as well, okay? So, we'll be looking at arrays in C programs. We will use multi-dimensional arrays in C programs. We'll declare and use simple structures in C. We'll declare and use simple structures in C. And we will also look at some of the user-defined data types, which is created by using structures. Now look at this lecture slide. What do we have over here is a daily temperature reading of a pressurized chamber. If you see over here, I have about 12 different readings. Okay, now I can store these 12 different readings in 12 separate variables. Yes, I can do it, but it won't be efficient management of data as far as programming is concerned. Why? Because I can store all these 12 readings in one variable rather than 12 different variables. Okay, much so because if you see, all these readings are of one data type, which is float data type. So it makes sense to create one variable rather than 12 different variables. So I can store it in one variable having 12 different sections. Now observe, in the previous slide, 12 different variables. In the next slide, one variable. Okay, one of you who's making noise, please switch off your microphone. Okay. Mute your microphone so that it doesn't disturb the session. Thank you. Now, what we do, look over here. I have got one variable called temp. Okay, if you observe, it's the same name temp, but it has 12 different sections. Okay, it starts with the first section, which has got a unique address called 0, and the last section, which has got a unique address called 11. So from 0 to 11, we have got 12 different sections. Okay, so this is an array. Okay, what is an array? What definition would be used for an array? Simple. A series of variables of the same data type which are grouped together under the same name. Okay? But how do we remove the confusion? Very simple. Every section is given a address. Okay? Every section of the array has got a subscript address, a subscript name. And a subscript address always starts with 0. Okay? Look over here. I'm creating an array. The name of my array is number. An array is just like a normal variable. A variable should have a name, should have a data type, and it should have a value. What's the difference in array? Very simple. We use a square bracket and we put a number inside it. The number specifying the dimension, the size of the array. That means this array can store 3 values. Okay? This array can store 3 subscript from 0, 1, 2. 0 to 2, 3 subscripts. Okay? And another thing about this array is the data type is integer. That means it can store only integer data type. Okay? So these are some of the things, basic concepts that you should understand. Okay? Try and pay attention, my dear students, and try and understand to the best of your ability, because you're going to take this knowledge and implement it in your assignment. Remember, you have an assignment to do, which is worth 60%, okay? Because of the MCO that we are under, okay? We have replaced the midterm exam and the final exam with an assignment, an open book assignment, but you have to know the concepts to implement and work it out in your assignment to do the programming, okay? Now, continuing with that, I have created a variable, a special variable called an array. How do I know this is an array? Very simple. Beside the name, there is a square bracket mentioning the size of the array. In this case, the size is 3. So, I just created an array called number consisting of 3 subscripts. Okay, 1, 2, 3. Consisting of 3 subscripts. Okay, now, how do we store values inside the array? Very simple. Okay, before that, the subscript 0 would be the first subscript, the second one would be 1, and the third subscript would be 2. So here we are with the 3 values for our array. Okay. Now, how do we store a value inside the array? Very simple. We give the name of the array. We mention the subscript number 2. Number 2 means this subscript. We are talking about this subscript. And store the value 4 inside this subscript. That's it. So it will store the value 4 inside the subscript 2. Okay? So it's very simple. It's no rocket science. You create an array, you give a size, a dimension to your array, and then you store a value inside it. Okay? By mentioning the subscript number. Okay? That's it. Arrays are very simple. Now, there are certain things we should know. For example, can we do this? In this case, can I do this? Can I say number subscript 0 is equal to 2? Observe, can I do this? Subscript 0 should have the value 2. I cannot do that, my dear students, because the 2 subscript, if you observe, is enclosed in single quotes. Single quote means character. What is the data type of our array? Integer. Since it's integer, you cannot store a character. So this is a no. You cannot do this. Okay. What about this? Can I do this? In the subscript 1, that means this one, I want to store the value 4.7. Can I do that? Can I store the value 4.7?
No.
Very good. Why? Because the array is data type integer. Since data type is integer, I cannot store a float value. Actually, I can. But what happens is the 0.7 value will be removed. Only 4 will be stored over here. Get it? Because the data type is integer. No decimal points will be stored. Okay? Now, next we move on to another example. Yes. Can I do this? In the tree subscript, store the value 77. Do we have a tree subscript over here? There is no tree subscript. Okay. Maximum is 2. So this is also wrong. Okay. Remember, you have to mention the subscript address to store a value inside your array. So this is a simple one-dimensional array that we create. You can also create a two-dimensional array. Okay. A two-dimensional array will look something like this. Okay. Some of you who come from foundation, you must have seen this slide before. I create a two-dimensional array. Okay. The first one represents the number of rows. The second one, the number of columns. So over here, I have got 7 rows and 10 columns. Okay, 7 rows. 1, 2, 3, 4, 5, 6, 7. Columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, starting from 0 to 9 would be 10 columns. Okay, why do I need 10 columns? Because Wednesday consists of 9 characters. Okay, plus remember, whenever you store a string inside an array, at the end you have to put a null character, \0, which is a null character. Okay, so this is an example of a two-dimensional array. Do we have a three-dimensional array? Yes. Do we have a four-dimensional array? Yes. Okay. When you study computing and computer graphics, you can see it can get as complicated as you want it to get. Now, look over here. Printf, okay, a string, C weekdays 0. So what will be shown? C weekdays 0. Obviously, Sunday string will be shown. What about the second one? Printf, C weekdays, 4th row, 1 column. So it will 4th row, it will show the 4th row and the 1 column. So what will be shown is H will be shown on the screen. Okay. So these are some of the basics that you need to understand and practice using your Dave C++ software so that you're adept in programming and you can do your assignment. Okay, assignment, remember, 60%. Okay, very easy to pass the unit now by just doing an assignment and submitting it. Moving on. Now, you can also create a matrix and initialize it and store value inside it by using the concept of arrays. Okay, just as we have got a two-dimensional arrays, over here, I'm creating a two-dimensional array. What is the name of my array? It's called matrix, consisting of row and column. Okay, now using two variables, I and j. The first, I, will be inside a for loop, will represent the rows. The second one will represent the column. Okay, and now I can initialize the value inside and store value inside my matrix. Remember, row, column. Okay. Yes. Just a second. Okay, moving on. Yeah. Now, observe over here, we are creating an array called vector. Size is 100. And using a for loop, what am I doing is I am displaying, okay? I am displaying the value, okay, inside the array. Here, if you see this comment entry, first you have to store the value inside the array. Then only you can display the value. The section where they have stored a value inside the array called vector is not shown. Okay. Another example, I'm creating an array called vector. Size is 100. Okay. And here, first, what I'm doing is I'm displaying the values inside the vector and multiplying it by 5. Okay. Then I'm creating another variable called j. Sorry, the variable is created. I'm giving it a value of 5. Okay. And then I am displaying the value of the array by multiplying it by 5 and then adding it by j. What's the value of j? 5. Okay. So you can do this kind of operations on your array. Now, if you observe very acutely in these slides, you will see that whenever you have got an array, one-dimensional or two-dimensional, what is used is a loop, okay? Because an array and a loop are made for each other. If you don't use a loop, you have to traverse the array individually, which is very troublesome. But when you use a loop, it's like very simple. You just have to initialize it, and you always initialize it to 0. Why do we initialize it to 0? Because array subscripts always starts from 0. Okay. Now remember, yeah. Now remember that wherever most of the times you see an array, you will see a loop structure being used along with it. Okay. Now look at another example. Yes, accessing all elements in order. Look at this example. I'm creating an array. Size is 100. The dimension of the array is 100. The name of the array is vector. It's a float array. Now I'm using a loop. Okay. And what am I doing inside the loop? I'm saying that, hey, display the value of the loop. Now, what is the problem with this code is I have not initialized my array. Since I have not initialized my array, okay, since I have not initialized my array, my problem is I will get something like this. It will show me the value, but since I have not initialized, can you see the strange values that I'm getting? It will be all weird values. So before you can display the value inside your array, you have to first put a value inside. That is called initializing an array. Okay. So what I do is, you see in this example, I first initialize my array. Look, what do I initialize it to? Look, the array is 100 dimension, size is 100. So I start from 0 and end at 99. Okay. And then I say, hey, the first array, I means 0 array, value is 0. Then what happens? The value of the 0 subscript is 0. Then it increments, 0 becomes 1. The value of 1 subscript becomes 1. 2 subscript becomes 2. 3 subscript becomes 3, and so on. And then display the value. So if you run this program, now you see after initializing, you get all the values right from 0 until 99. Okay, the value should be stored properly inside. So remember, if you want to see a value inside your array, you have to initialize your array to a value. If you don't initialize, then you get strange values like this. Okay, we don't want that. Now, initializing an array is very important. Over here, we are initializing the array vector as in the previous example. We can also do complex mathematical operations on an array, like this example. What am I doing? I'm creating Alex, can you switch off your, is it, I'm sorry, maybe somebody else. Forgive me. Can you switch off your microphone? Okay. Okay. Thank you. Now, if you look at multiplying two vectors together, I'm creating 3 float values: vect1, which is an array, vect2, which is an array, and result, which is a float value. Result is a normal variable. Now, first, again over here, populating the values of these vectors is not shown, but remember you have to first populate. So I initialize my result. Initializing vect1 and vect2 is not shown. Next, what I'm going to do is I'm going to use a float value. Okay, if you look over here, I'm using a float value. So result is initialized to 0.0, and then using a for loop on the float, sorry, on the integer data type I initialize it to 0. Why do I initialize it to 0? Because an array subscript always starts from 0. Okay, and this will continue 100 times. From 0 to 99 is 100 times. The loop will continue. So every time it goes inside a loop, the value of result will be calculated. Okay, here I'm using a increment assignment operator. Every time the result value will be calculated by multiplying the first subscript of vec1 with the second subscript, sorry, with the first subscript of vec2. Okay, so here it will calculate, it will multiply the 0 subscript of vec1 with the 0 subscript of vec2. And then this will continue by increasing I. Then the first subscript, sorry, the number 1 subscript after 0 comes 1. The 1 subscript of vec1 will be multiplied by the 1 subscript of vec2, and then 1 becomes 2, and so on, all the way to 99. Okay, so you can do all kinds of mathematical operations on your array. So summing it up, what is an array? Okay, remember, okay, arrays are data structures that group elements of the same data type. Remember, this is very important, of the same data type. Compiler must know the name and type of a number of elements in the array. Okay, so you have to say the data type, okay, and what is the size of your array, and must be declared before you use your array. An array can be initialized when declared. Example, I'm creating an array. The data type of my array is float. The name of my array is vector. What is the size of my array? 3. And while declaring it, I can store values inside it by using the curly braces. Can you see this? This is how you can store values inside it. Since this is float, you don't need to enclose it in single quotes. For float and integer, you don't enclose in single quotes, but for character, you have to enclose it in single quotes. Okay? Now, array dimensions can be defined as symbolic constants. Access elements by using an integer index. Okay? Or any expression that evaluates to an integer. Okay, remember the expression should be an integer. Index is used to point to specific element of the array. You can point to any element. For example, here the index size is 3, so that means the address will be 0, 1, 2. Okay. Character arrays are treated differently. Okay, just remember in character arrays you have to enclose it in single quotes. Okay. Now, in mathematics, matrices can be represented, especially in computing. We use a lot of matrices for our calculation. Even in computer graphics, if you study computer graphics, we use a lot of matrix calculation. Okay. In fact, in computer graphics, you have got not two-dimensional, mostly three-dimensional. The first one would be the row, the second one would be the column, and the third one would be the distance from the screen. Okay, add to that shadow effect and light, and you can create artificial objects which look exactly like real objects. How do you think they create all your computer games and all those CGI movies that look very real? Okay, they use computing secrets and concepts, and all those objects are represented by using a matrix. Okay, now look over here. Initializing a matrix. I have a matrix. This is a two-dimensional array. The name of the array is matrix. This is row. This is column. Okay, now I create two variables inside this, I and j. Now using the for loop, the first one represents your rows, the second one represents your column. So this is the first row of the matrix, and this is the first, starts with the first column, then goes to the second column and the third column. So here matrix J represents your row, I represents your column. So this means for row 0, column 0, give a value 0, 0.0. Then increments for row 0, column 1, give the value, and so on. Then it changes to row 1. And then it changes to row 2, 3, and so on. Okay, until row 99. For every row, it will always give a value to the column. Again, column is also from 0 to 99. You can also transpose a matrix. If you remember transposing matrix, what is transposing matrix? Very simple. The concept in mathematics is you take the row and make it a column. Okay, you see? You take a row and transpose it to a column. You take a row and transpose it to a column. Okay? In this case, we have got a 3 by 3 matrix. Transpose it, take a row, make it a column. Take a row, make it a column. Take a row, make it a column. Okay? So, how do we transpose a matrix? How do we write a code to transpose a matrix? You can do it for any kind. For example, here, I have got 3 by 3. Here, I have got 2 by 3 matrix. Now, very simple to transpose. Okay? Look over here in this example. How do we transpose? I create a matrix. The size of my matrix, a two-dimensional matrix. The name of my two-dimensional array is matrix, consisting of 100 rows and 100 columns. So starting from 0 to 99, 0 to 99. I also create another array called temp, also a float data type, also having the same dimension. I create two variables, I and j. Okay. Now look over here in this example. The first for loop is always for your rows. The second for loop is always for your columns. Okay. Now, what am I doing is I am giving a value to my temp array, a two-dimensional array. Whatever is inside my matrix array, I'm storing it inside temp array one by one. Can you see? Now imagine if you had to do this. Imagine if you had to do this without a loop. You have to go from the first row, first column, all the way until 99 row, 99 column. You'll go crazy. That's why loops and arrays are made for each other. Okay, so what we are doing in the first loop over here, if you observe, we are giving the value of matrix to temp array. Okay, now in the second one, if you observe, what we are doing is, hey, we are changing the value of matrix, okay, ji, there you go, matrix ji is equal to one by one. We are changing the value to, observe, temp ji. Initially it's stored as ij. Can you see we changed the ij to ji? Can you see that, my dear students? So you are transposing the matrix. Okay. Now it will be very important for you to do a tracing. Okay, to understand this completely. Now, why do you need to understand this? Perhaps you can implement it in your assignment. Okay, if the assignment needs a case that you have to implement, you can implement. Moving on, let's look at this example of simulating heat flow. Okay, simulating heat flow. Your company is designing a new metal alloy. You have been asked to write a program to simulate how heat passes through the new substance. Your program will simulate the following situation shown in the next few slides. Now, over here, I represents the sections. How many sections we have? 1, 2, 3, 4, 5. Left section has heat passing through it. Right section has heat passing through it. Although the heat temperature will not be the same. Now we have to calculate how much heat is dissipated from one section to another section. Okay, so how many sections we have over here? 5 sections, for example. Okay, so here each section I represents. So next section is I plus 1. The previous section is I minus 1, and so on. And the heat represented by H over here. Okay, so over here U, IT is the temperature in segment I at time T. So using this formula over here, we can calculate the heat dissipation. Let's just go through it again. This is a graphic of supplying heat to one section. Now in hours, remember, we are supplying heat at 2 sections, although not the same temperature. Okay. Now, as time passes, heat flows through each segment of the rod. Okay, if you remember what you studied back in thermodynamics and physics. So here we are creating a simulation program that is going to simulate the transmission of heat in a rod. So heat dissipates. So each segment gives some of its own heat energy to its neighboring segment. So if we let U represent the temperature of segment I at time T, then U plus 1, which is the temperature of segment I, 1 time unit later, is given by the equation as shown here. Okay. So using the formula S is equal to C divided by H squared. C here is a constant determined by the thermal conductivity. Okay. Specific heat and density of the material. So we are going to calculate by using of course, a loop, but the dissipation is going to be calculated by using a loop and an array. Okay. Now, what is required in our program? Number 1, temperature of the 2 heat sources. How much of heat is supplied from the left how much of heat is supplied from the right. Second, initial temperature of the rod. What was the first temperature of the actual rod? What is the temperature at each of these sections? Initial temperature. Third, number of segments. How many segments do we have? Okay, we have to calculate that as well. Once we have that, we have the formula, we can do the calculation. And number of time units to simulate. How many seconds? First second, how much of dissipation occurs? Second, how much dissipation occurs? So these seconds we will be simulating in our loop. Okay. For example, after 1 iteration, 10 iteration, 20 iterations, and so on. Okay. And what is the value of the constant? C. Okay. Now, we have to know the behavior of our simulation program. So we have to prompt the user for these initial values. First, the user has to enter the temperature of the two heat sources. What is the left heat source? What is the right heat source? What is the initial temperature of the rod? Before applying any heat, what was the initial temperature? How many segments the rod is going to have? The temperature differential tolerance to stop the simulation. You see, when the loop is going on, you don't want to, remember when we studied loops, we don't want to create infinite loop, right? Because infinite loop is bad. Infinite loop is a virus. The program continues forever, okay? So we want to stop at certain point. So what we have to do is we have to have a tolerance where we say, hey, stop. Now the heat dissipation is okay. It is the simulation software has to stop here because this is the tolerance level, okay? And the value of the constant C has to also be calculated, okay? Print out the initial temperature of each segment. Then for each of the time units in the simulation, what we have to do is calculate and print out the temperature of each segment after one more time unit has passed, okay? For example, after 10 iterations, what is the segment temperature? After 20, what is the segment temperature? After 30, and so on. So that's the whole idea of creating a loop, okay? So we'll repeat this calculation and graph for each iteration until we achieve our equilibrium. This is the equilibrium that we talked about, okay? Now, how will our algorithm look in this situation? Remember, when you solve a problem, algorithms can be created in any way you want, okay? There's always a way to improve an algorithm and make it better, okay? You just have to think and come out with a new solution. So we have to define two arrays, an old array and a new array. What is old? Old will be the value in the old section. New will be the value inside the new value inside the section. Remember, the heat is being dissipated. So old value at one unit, at one iteration, will be changed to a new value because heat is constantly dissipating. This is much more difficult than an actual lecture hall, my dear students. This is my experience, okay? I hope you all are still there. Can someone say something and say, you hear me? You hear me? If you haven't fallen asleep, someone please say something. Anyone?
Yes.
Thank you very much. Okay. So we initialize the array, the old array, and initialize the temperature. First would be the left heat source, and last would be the right heat source. Okay. So we need a loop to calculate the new temperature every time. Okay. Remember, each loop over here would be iteration. Okay. What would be the data type of the loop that you're going to use? obviously it's going to be an integer. Okay, so calculate the new temperatures. Calculate what will be the data type of the temperatures. Obviously float. Okay, compare the new temperature to the old to see if within tolerance. If it is within tolerance, then you get out of the loop. You don't need to do the dissipation anymore. Okay, and then copy the new to the old. Why do you have to copy the new temperature to the old temperature? Because as the heat dissipates, the new temperature will be added to the old temperature, and then the old temperature will be increased to new. Then the new again will be given to the old temperature. Okay, and display the old. Now all you have to do is take this algorithm and put it inside a program. Okay, so how do you initialize your array? Construct old segments, construct new segments, set the old, okay, that is the left temperature, set the old last to the right temperature, and create a loop to initialize other segments. So this would be the loop to initialize every segment. Okay, what is the initial temperature of each segment? Okay, now putting that into a pseudocode, we have got a loop over here. We have used a while loop, a do while loop. Remember the difference between while loop and do while loop. In this situation, do while loop, what happens is the loop is executed at least once, okay, even if the condition is false. Okay, so the moment it goes in, we have a over here Boolean data type equilibrium is set to true. Okay, here is our first for loop where we give each segment, okay, a temperature, and then we calculate the temperature by putting it inside a new array. Okay, and we have got another loop. What do we do in the second loop? We change the value of old to this new value. Okay, for every segment. Can you see? For every segment. How many segments do we have in this case? We have got 5 segments, if you remember our ROC. Okay, so every time this will continue as far as the equilibrium is false. Once the equilibrium, you see, if the tolerance is greater than the tolerance, the equilibrium is changed to false. Once the equilibrium is changed to false, what happens? It gets out of the loop. If this if construct is not true, the loop will continue until this has been achieved. Okay? So when you run this pseudocode, you see, after zero iteration, after zero iteration, what happens is, you see, this is the initial segments and the temperature. Okay, there we go. This would be the initial temperature given from the left 100 degrees centigrade, from the right 180 degrees centigrade. Look at the dissipation, not much dissipation. Okay, no dissipation because it's the beginning of the program. But what happens after 10 iteration? Can you see the dissipations in different sections? Can you see, my dear students? After 415 iterations, you see the dissipation is much more pronounced. So this will be continued until they achieve the so-called equilibrium. So this brings us to the end of the concept of arrays. Now let's move on to the concept of structures. Okay, I have a picture over here of a egg tray consisting of eggs. Okay, the idea being that egg tray can only store eggs. Arrays can only store the same data type. But what if you want to store different kinds of data type? Can I do this inside the array? Can I store a character where I have to store integers? No, I cannot do that. Arrays don't allow me to do that. Okay, we can only store the same data type. But what if you want to store different data types? Then we use a structure. Okay, so a structure is pretty much just like an array, except you can store different data types, character, integer, float, all together. Okay. How do you group together data elements of different data types? Very simple, use a structure. How do you reduce the complexity of data? By using a structure. Okay. You can store complex number, 2D, 3D objects, images, and so on. We'll be looking at some of the images and the techniques. Okay. Now look at this 2D object representation example. I'm using a structure. Now observe my main function is right over here. Okay. And I have a structure. You see how a structure looks? If you look over here, a structure, those of you who have come from Foundation, remember C++, when you create a class, how it looks? Your structure is very similar to a class. Okay? Not exactly the same, but very similar. So I'm creating a structure called line. So this line is going to be like a data type, user-defined data type, your personal data type. So inside the structure line, if you observe, I have got 4 variables, all of integer data type, x1, y1, x2, y2. I repeat, inside the structure line, I have got 4 data types. Now look at the main function, how I use the structure. I create a variable of my structure line. I call it line 1. Now, what's the importance of creating a variable of line 1? Sorry, of line. The data type is line. The variable is line 1. The importance is line 1 can access x1, y1, x2, y2. So it can access all these 4 variables over here by using the dot operator. So you can say x is equal to line1 dot x1, line1 dot y1. Okay, so this variable can access all these 4 variables by using the dot operator. So you can see the complexity. Okay, using a graphical option, you can represent it even in a graphical option. So structures increase the complexity of our programming. Okay. Yes, this is the same thing, representing a 2D object by creating a structure. Here, the name of my structure is line. Using my structure, I create a variable called line1. Line1 can store these 4 variables. Another example, now I'm creating another variable, line1 of line data type. Remember, it's a structure. So line1 can store how many variables it can store? Line1 can store x1, y1, z1, x2, y2, z2. Okay? By using the dot operator. So this can move on. Now let's put this in actual programs. Look over here. I'm creating a structure called complex. Complex has got 2 variables, real and let's say imaginary. Okay. So what I do is I create 3 variables of the complex structure. Okay. This is my complex. So A, B, C can store real and imaginary. So that's what we're doing over here. C.real is equal to A.real times B.real plus A.imaginary times B.imaginary. Then C.imaginary is equal to A.real and so on. Okay. So the whole idea of a structure is when you create a structure, okay, your data type can access whatever is inside the structure. Okay, so here the data type is complex. I'm creating 3 variables of my structure complex, and all these 3 variables can access real and imaginary variables. Now, you can create your structure by using this format. You can also create a structure by using a specific keyword known as typedef. How? Like this. You say typedef struct, okay, and the struct data type name is going to be line, and line has got x1, y1, x2, y2. Now you can create variables of the line data type as we are doing over here. I'm creating a variable line1 of line data type. That means line1 can store x1, y1, x2, y2 variables as shown over here. So actually, you can either create it in this way, or you can use the typedef keyword. As shown over here, the same example like before, but now we are using typedef command. Okay, I'm creating a structure known as complex, and then I'm using the complex structure and creating 3 variables of the complex data type. So A, B, C can access real and imaginary inside the complex structure. You can also create a structure of structures. You see how complicated it can go. Creating a structure of structures. Look over here. I have a structure called date. I have another structure called time. I have got another structure called stamp. Okay? Now, observe my structure date consists of month, day, year variables. Time consists of hour, minute, second variables. But wait a second. Stamp consists of date structure and time structure. So this is an example of structure of structures. Okay. So let's just do a quick tracing on this. Okay. Look over here. We have got the date structure inside stamp and time structure inside stamp. Okay. You can also use structures and arrays together. Okay. You can use all kinds of data structures in a marriage with each other. Okay, depending on your need. Over here, I have got a structure called student. Now, inside my program, let's just have a quick tracing. Look at this program, the same program as this. In this program, I have got a structure known as student. Okay. Now, what I do is I create a array class of the student structure, and the array can store 3. That means array subscript start from 0, 1, 2. So John Doe will be stored in the name. Remember, when you create an array of the structure student, the class over here, array, can store name, test, final. Remember, okay? So John Doe will be stored for name, okay? And the second would be, the marks, the test marks. Remember, 3, 65, 73, 80. So 65 will go inside the 0 subscript, 73 inside the 1 subscript, and 80 inside the 2 subscript. Okay? And the last one, which is 0, will be stored inside final. So this is only for the class 0 subscript. Now, then for the 1, then for the 2, and so on. Okay? So you can see after you are finished storing the data, now you can use a for loop to calculate the average of all these marks for each of these students. Okay, so the sum will be calculated by averaging all of that. Okay, in this place you can see you're averaging the marks and displaying it to the user. So this program shows you a combination of structures used with arrays. We also have enumerated types. Okay, by using a structure, for example, enum, I can store clubs, diamonds, hearts, spades together. Okay. For example, over here, I create suit is the name of my data type over here. Okay, the structure. So suit card. Okay, so card is equal to diamonds. So this card will be my variable of the suit structure. I can also say card is the variable of the suit user-defined data type. So what can card store? It can store any of these values. Okay, so card is equal to diamonds. So using it in switch, if it's, for example, case is hearts, clubs, or diamonds. Okay, so you can just implement it in a program. Possibilities are endless. Now coming to more complex uses of image processing in structures and arrays. For example, this is a picture of Io. It's a moon of Jupiter. If you observe this picture, it is a bit pixelated. Can you see that? Now I'm using this picture of Io, moon of Jupiter, and I want to, for example, make it less pixelated. Okay, I'm going to follow a standard averaging algorithm. Okay, now we need an image type. Okay, this program is given to you in Moodle. You can have a look at it. We can have the number of columns, number of rows, maximal pixel value, and the red, green, blue ratio. Okay, where they are placed. Okay, you can see the red, green, blue placement over here. Okay, and the picture I'm using is a PPM, a portable pixel map file. Okay, so let's look at this picture. How do we do averaging? Okay, so what we do is we look at current pixel, okay, P0, and what we do is we look at the one above it, beside it, before it, below it, and we add them together and divide it by the number, which is 5. Okay, and this is how we average it. Okay, in matrix representation, you have to mention the pixel, which is the number of rows, which row and which column. Okay, now how does that work? Look over here. Look, for example, the red value, remember, using the formula P0, 135, plus then P1 is 142, then P3 is also P2 over here is 136, then P3 is 142, and P4 is 136. So you average it, add them all together, divide it by 5, average it, so it gets 138. You do the same thing with green value, you do the same thing with blue value. Now that you have this algorithm, all you have to do is implement it inside your structure. Create a structure for red, green, blue, okay? And create a structure for your PPM image, okay? And then read the information. Ask the user to enter the information in your main method, okay? And once you have this, input the image as shown in this code. We are inputting the image, and now we are processing the image by using the averaging. Okay, inside the for loop, for each section, if you see, what am I doing? For image height and width, I am going in every time and averaging it. So what does this do, my dear students? Okay, what does this do? Very simple. The output of the image to be shown, okay, the red value, green value, and blue value, the output would be a much lesser pixelated image. So I take this pixelated image and reduce the pixelation by using this algorithm. Okay, so that's what the basic idea is. Okay, so these are some examples of how we use arrays and structures inside our programs. So what you have to do is perhaps see how you can implement it inside your assignment. Now, most of you have already done the labs for arrays because Mr. Suresh conducted the lab last week of this without us conducting the lecture. No worries. You can look at those labs again after going through the lecture. So this week, actually, I asked Mr. Suresh there won't be any labs because he has already conducted the lab last week. He didn't know that last week was a week free. So what we do is we go through the lab exercises after going through this lecture slide, and perhaps we try and understand how we can implement this inside our assignment. Remember, your assignment is very important because it's worth 60%, my dear students. Okay, and remember, this week you have to also do your lab test. The second lab test is available on Blackboard, so please go there and attempt it. Okay, I'm going to give an announcement for that also, perhaps sometime this week. Okay, that would be available just like your lab test one until 5th June. Okay, so next week we are going to do functions. Next week is same time, 2 p.m. I hope to see more of you. So just a second. So I stopped the share. Now, yeah, we have come to the end of this session, my dear students. Wow, more than 20 students, I guess. I hope you understood the concepts better after going through this. I'll try to put the video online as well for you to refer to it. My dear students, I want to tell you something important. The projects, the assignment, please do it in isolation. Do not share with your friends. The code should not be similar to your friend or anybody because we are using a software which checks that. Don't get into trouble. Try to make sure that you do your own program without helping anyone, or rather without without seeing anybody's code. Okay, because otherwise it will be a collusion case, and you don't want to repeat the unit. Okay, and the it's 60%. It's very huge marks. Okay, so make sure that you start your assignment. If you haven't started already, start it today itself. Just play around, go through it, and see how best you can solve it. Okay. Wishing you all the best. Until next week, we see each other. Thank you very much.
So I have a question.
Yes, please carry on.
All right. So you said there was the assignment, but the thing is, the questions I don't see on Moodle, and I'm not so sure if it's on Blackboard or not because I only see the submission.
Hey, it is already there. Excuse me. I've already put it on Moodle. Please check again. Go to the last section. Go to Moodle. The end section, you will see assignment. Okay.
Okay.
Yeah. If you don't still see it, let me know. What I'm going to do is, again, I'm going to go to Moodle and check it. I uploaded it yesterday itself. Have you checked it?
Yeah, I just saw it.
Oh, can you see it now?
Yes, I can.
Yes. So start dabbling and opening it and write a pseudocode, because every section there is a marks rubric. Okay. Look at the marks rubric. It will be very easy to get high marks out of 60 in this in this assignment. So please avail of this opportunity that the MCO has given us, the lockdown has given us, and try to make sure that you do very well. Okay. Anybody else has
So
any question? Yes.
the submission is on the 15th, right? To confirm. Is
Uh,
it?
is it
Or
15th or 5th? What is the
5th? Oh, okay.
yes, 5th. Yes. Not
All
5th,
right.
before 5th.
Or before 5th of
Yes.
May. All
Yes.
right.
If you finish it, let's say after 10 days, you can still submit.
Uh, okay. And for the pseudocode in PDF, it must be typed out lah.
Yes, yes.
It must. All right.
You can do it on a paper first and then type it out. That's why I told you. I told you in my announcement yesterday, this assignment cannot be done last minute. Okay, do not do it last minute, my dear students. Do not do not think that I will do the assignment during the last 3-4 days. No, that is a recipe for failure. Okay, start doing it little by little today itself. Remember, it's open book. Okay, you can start, and please do not ask questions relating to the assignment to Mr. Suresh or myself. You have to solve it on your own. Okay, and do not take the code help of your friends. You don't want two code to look exactly similar and get into trouble. Any other questions? If you cannot think of any questions now, you can write it down and perhaps ask me next week or email it to me. Okay, so can we stop now, my dear students? Thank you very much for your attention. I'll see you all next week. Okay, uh, and if you haven't started your assignment, please start it as soon as you can, perhaps today or sometime this week. Thank you very much, my dear students. And
Sir,
yes,
yeah, one last question. For the pseudocode, when we write the pseudocode itself, we can include some programming language into the pseudocode and like our own explanation, just like in the lecture notes, is it?
no, don't put any programming language. Don't put C language. Look at how the pseudocode examples are given in the lecture slide. Use something like that.
Mhm.
Okay? Okay?
Okay.
Yes. If you look at the lecture slides in Moodle and in Blackboard, many pseudocodes are given to us. So we follow those examples. We do not, my main point I'm trying to tell you is, do not use keywords. Do not use C programming keywords. Okay? Because if you look at the marking rubric, the pseudocode also has got certain marks. And remember, when we mark, an excellent student deserves more mark than a good student, right? So keep that in mind. Don't make mistakes. Okay. Okay, my dear students. Any other question? Anyone? Like I said, if you cannot think of any question now, you can ask it later. Okay. Thank you very much. We had a good session. Uh, we'll have the same thing next week. Next week will be functions, correct? Okay. Thank you very much, my dear students. I'll talk to you next week. Okay.